This is chapter 11, inferences about population variances. There are two sections in this chapter. The first one is about one population variance. We'll be looking at confidence interval and hypothesis testing for one population variance. And section 2 is for two populations. We'll have two population variances. We'll look at hypothesis testing for the two population variances. So we'll start with the first section. So we have a single population, and sigma squared is the population variance. In other words, sigma is the population standard deviation. And our objective is to develop a confidence interval and perform hypothesis tests about sigma squared, the variance, or sigma, the standard deviation. They both are equivalent. So we take a sample, a random sample of size n, and compute the sample variance. S squared is the sample variance, and of course take a square root of that, and S is your sample standard deviation. Then this ratio, n minus 1 times S squared over sigma squared, will follow what is called a chi-squared distribution. Chi-squared distribution is similar to normal distribution, except that it is skewed to the right, and it can only take positive values. So it has a parameter which is degrees of freedom, which is n minus 1. So if this follows normal distribution, then this ratio is equal to a chi-squared value that we get from the chi-squared distribution. So it's only in the positive side, and it has a skew to the right. So and chi-squared is always positive. Now this is the central 95% for the confidence interval, so which means you have a right side chi-squared value and the left side chi-squared value. The left side chi-squared value is given by this notation, chi-squared sub 1 minus alpha over 2. The right side is chi-squared sub alpha over 2. The subscript indicates the right side probability. So here it is chi-squared sub 0.975, means on to the right side there is 0.975 probability, and that is 1 minus alpha over 2. And this chi-squared, the subscript of 0.025, means there is 0.025 in the tail, and that is alpha over 2. Now we can take this chi-squared formula and set it equal to each of these two chi-squared table values. So for the left side tail, so n minus 1 S squared over sigma squared is equal to chi-squared sub 1 minus alpha over 2. Now exchanging places here, we can rewrite it as sigma squared less than or equal to that. And similarly, we can do a rewriting for the right hand side chi-squared value, and that will give you this expression. So this gives us a confidence interval for the variance. So our confidence interval for sigma squared is given by that is to the left side and that is to the right side. So sigma squared within these two limits is the confidence interval. Now of course we take a square root of both sides and the middle, so you get the standard deviations confidence interval. So you compute the confidence interval for variance and simply take a square root of the numbers, and you get the confidence interval for the standard deviation.